Kale.
Perfect.
What the Kale? So I'm going to show some of these graphs. Is take our invocation count to astronomical heights compared to where we had been. So I've shared this graph multiple times. This is like, there are two graphs that, well, really just this graph that I'm focused on this year. There are other graphs that I care a little bit about, but this is the primary one as I measure like what I'm trying to do this year. And that's just to make the network very active. Activity attracts activity, especially in this market where there's so much competition, trying to decide what chain do I build on, finding a chain that other builders are building on, other users are using, is a really good signal. It's a helpful signal to know where should I spend my time and energy. And if you look prior to oracles, I don't know if you guys can see my little highlight. Can you see my highlight, Elliot, as I highlight this?
Yes, I can.
Okay, so this is before oracles. So there's just not, I mean, it was, early days of Sorbonne, but like Stellar's been around and we'd hyped Sorbonne for a long time. There's just like not a whole lot going on every day. And then we launch oracles and we get like Reflector, and it's pumping out some transaction numbers, but this goes on for months and months and months. And this is like DeFi is launching, SCF projects are going live. And it's a lot of DeFi stuff, which to be honest is hard to understand as like a user. I think protocols can implement them. Other dApps can implement them in the background, but there's just relatively little activity. And some of this you could attribute to the bear market. And once we make a turn, we start seeing more activity. But if I show another graph here, Kale versus other. So I'll get back to that one in a minute. But this is, the blue is anything that's not a Kale transaction, and green is everything that is a Kale transaction. It's not just a bull versus bear market thing. That certainly is there. I mean, you can see the blue activity corresponds directly with some increased activity I would attribute to the bull market. Lots of DeFi stuff starting to happen. But this is also, there's more activity just happening in general on Stellar, on smart contracts, but really all of it is Kale right now. So this to me like proves the point that people really just want to do fun stuff that's simple on chain. This initial block right here, this is before we had web miners. So this is just CLI miners, and it's about half the traffic of everything else. I introduced a nice little bug that for a period of time broke the contract, and so we went right back to pre-Kale days. I fixed the contract and introduced web mining, and then we're 3xing normal invocations. That's really cool to see. Again, there was a hypothesis that if we didn't have to download a CLI tool and install Rust, and you could just go to a website and start farming Kale, it would be a really cool experience. This is using LaunchTube, so you don't need XLM. It's using passkey wallets, so you don't have to get a G address. It's all very transparent, feels very Web 2-ish, but it's real on-chain activity. And I was pretty happy with this. A lot of what I was planning on doing once I got back from Denver was just starting to add more utility, and maybe using Kale as like a base asset that people could use. I'm working, again, I mentioned, on an AI service. And how I'm going to gatekeep, people from just using all my AI credits is you have to spend some Kale to create gens, to run generations. So that was still planning on doing that just to add some utility there. But I have had a target. I've got 2 targets for this year that I had set a few months ago, and one of them was in one day to get 100,000 transactions. A smart contract transaction invocations. So we're sitting down here right around, like, I think our highest was about 33. So not even that high. 33. And so I set a goal. I think if we're careful, if we're smart about it, if we create the right scaling logic and people are interested, I might be able to get us to 100,000 in Q1 of 2025. That was the goal. And then the next goal, which I'm now publicly sharing, but I've never committed to anything. My value is not tied to blah, blah, blah. My goal now is to get 100,000 invocations day over day, month over month. So like a 30-day rolling average. 30-day rolling average. At one of those rolling 30-day averages, we're averaging 100,000 transactions every single day. So what I didn't anticipate was that we would hit 100,000 very quickly. Again, I said it for quarter three. I actually was pretty sure that we weren't going to hit that because the web miner, while it was quite good, it obviously wasn't getting continued engagement and traffic. And that's pretty obvious. There's nothing to do with Kale, which is what I was going to add some utility to it. Well, the utility that was added over the last week was speculation. And again, the market cap is not high, but apparently you don't need much speculation to at least get these invocation numbers really, really high, which is super cool. I'm thrilled by these numbers because, again, my goal is not to create a super valuable asset. Again, that's up to the community. Who knows what will happen, but the goal that I have set is to get these invocation numbers up because vanity metrics are really important in making decisions for folks in this industry. I think sometimes vanity metrics get looked down, and there's bad ways to make vanity metrics, right? I could just spin up invocations on my side, but doing it organically, doing it through a legitimate project that's kind of quirky and interesting, community driven, that's the right way to get vanity metrics. So not all vanity metrics are created equal, but I think it is important to remember and like hold in our minds, vanity is $1 billion industry. We don't want to look down on some of those numbers. Again, there's a right and a wrong way to do it, but there's more than one way to skin a cat. To skin a cat, we've got to come up with a better terminology. To feed a cat, than just maybe some of the things that we've been focused on in the past. And I'm always going to be trying to find fun things for people to do on Stellar, whether it's the turret stuff that I built ages ago, Stellar Quest. Now we're working on more smart contract stuff, things that I've wanted for ages and ages with things like Color Glyph or this new AI project that I'm working on. A lot of that just wasn't possible until we had smart contracts and was going to be really hard without things like LaunchTube and smart wallets. But now that we have all those pieces, these parabolic numbers, they kind of surprise me as fast as they're happening, but this makes sense. This is what I believed Stellar could do for ages if we had all the pieces in place and the community ready to actually do stuff on chain. I will say, and it's worth mentioning because I'm not, let's say this carefully, I'm not a Stellar fanboy. I'm a blockchain crypto fanboy. And I think Stellar can win. But for us to win, we have to be honest about some of the challenges that we face, like other blockchains. And we address a lot of those. And I love working in a company that doesn't stick their head in the sand and actually addresses head-on problems like state bloat. And even though it introduces some dev friction with temporary storage versus persistent storage and having to keep your rent up, those are challenges, but they address the problem of state bloat, which is a significant problem that not enough chains are considering. So I love working for a company, but that doesn't mean that all questions, all problems go away. And so there still is, let me see if I can get back to that. Actual graph that I was at before. Let me go all the way back, see if I can find it. It's a little bit hard to navigate these Hubble things. That's that one.
If you click, there you go.
Yeah, so this is the one I want to look at. The red is failed transactions. And I don't know about you, but 12,000 failed transactions is not awesome. That's pretty bad. So those are transactions that charged fees and did nothing valuable. They just failed. Some of this is the contract design that I built in Kale, where when a block closes and a new block opens, everybody is trying to open that new block all at the same time, but only one user can do it. And if you do it, if you're able to open that block, your fees will be set to a certain amount. And I'm not talking about XLM, it's more the resources. The resources will be set to a certain amount. And then everybody else after that block closes will be different. You'll have to read instead of write a block. And so the bytes that you're reading, the bytes that you're writing are different. So everybody tries to plant all at the same time. And I'm still trying to trace down exactly how to address this issue. whether it's a contract upgrade, a launch tube, reconfiguration, if this is actually more on the simulation, because this is going to be a problem a lot of people are going to run into at high throughput, where people are like loads of people are trying to do the same thing at the same time, and the data changes, not just for a user, but for like the whole chain, where the amount of bytes that need to be written or read changes if two users are submitting at the same time for whatever reason. And this could be relatively frequent, and wasn't something that I really considered. And again, you can kind of see at normal levels, it's not a huge deal. But once we start to get to these really large numbers, I mean, we have more failed transactions per day right now than we had like all-time transactions when Kale first launched. So I really hate this number. One of my priorities right now is to start looking at how we can improve this, not just at the Kale contract level, but at simulation level and the launch tube level, because most folks are interacting with Kale through launch tube. So there is some opportunity to maybe on the transaction processing side to be able to decide whether or not a transaction is likely to fail based off of its resources. So that's a big piece that I'm looking at, is that. The other one that is a bit tricky is we're hitting thresholds. So Sorbonne has allocated 100. The smart contract lane, there are 2 lanes in Stellar. One is for like classic operations, and the other is for smart contract operations. You can have 1,000 operations in one ledger, and right now 100 of them are dedicated towards smart contract invocations, and we're starting to run up against that. There are also other limits, like total ledger limits for a particular ledger, like the number of bytes that can be read or written. There's a few others, but we're starting to hit those, and then it enters into surge pricing, where instead of transactions just being able to go through, you have to start allocating more fees to actually get included into those ledgers, or you get pushed to another ledger, which can then mess up your sequencing, which then your simulation is going to fail, because what you wanted to happen in the block that you originally simulated in, the state of the chain has changed. And so when you try to actually submit in the bumped block, because your fee wasn't high enough because of surge pricing, your transaction will fail because either the fees aren't high enough or now the state of the block has changed. I think that's where a lot of our failed transactions are coming from, is like a combination of both a state change and the surge pricing, which is pushing transactions from the block they were simulated and submitted in to the one, or the sent in. Simulated and sent in, then they get pushed, so that when they finally actually get committed to the chain, attempted to committed to the chain, things have changed too much. So the simulation is no longer accurate. So I'm not exactly sure the best way to resolve that, but it is really interesting. We would never have like run into these issues until it was probably like too late. So if we're going to run into them and need to change either RPC or SDK or the way we explain to people how to write contracts, it's better to run into those problems with like a meme like Kale than with like a big partnership or something. So that's kind of, I love that this is happening on the one side, because it means the network's actually getting used. These numbers look good. I'm very excited for the usage happening on chain, but there are certainly things that we need to continue to address to improve accessibility and be able to explain to developers how to write their contracts and write their transaction execution logic to ensure they have the greatest chance of success. Oh, right. If anybody has questions about the other graphs, I know that we've got a Dune analytics that's just like for smart contract stuff. So be sure and look that up. I'm really hoping that someone smart will write me the queries to get a Dune analytics dashboard just for Kale. I don't think I'm quite smart enough with SQL to figure that out, but that would be amazing. I'd really like to know, like, just to keep track of metrics, like what's the average, just like all the average metrics. How much are people making per block, both for those like different P cohorts. What's the average person making? What's the above average person making? Is there somebody that's making off with gobs of it? Would all be really interesting to know. I'm going to walk through quick, because I think there may be some folks or people that would listen to the recording here that have no idea how Kale actually works. And I've had some questions pop in that are pretty easy to explain, but are worth walking through really quickly before we get in. And then we will, hopefully, have time to actually work on getting a farmer stood up in a Raspberry Pi. Maybe. Actually, let me go ahead and start that process, because there's a well, I'm going to skip that part. Let's talk about this first. There's a part. Well, yeah. So the way that Kale works is like most mining contracts, mining tokens. You have to commit like compute power to generate a hash. The way that you generate a hash is just by giving a hash function some type of entropy, and then it hashes it. So you've got like well, does RunKit still work? I feel like that's probably not the best. Let's let me see. I've got an old.
I want to say no.
Yeah,
but I'm not sure.
One of these guys. Let me hold on one second. I'll bring it up on screen in a second once this loads up. I'll pull this up. So I've got a bun. Bun has become my new run kit for running JavaScript code.
Nice.
Let's just make a really basic hasher. So if you have like a buffer from, and we give it some sort of entropy like hello world, and we say toString, turn that into a hex, and this is our data. This would be like just hashed, or data that's been encoded into whatever format. So if I do, let me bring this over. Let me make this bigger. I can feel the squinting. I'm going to run a bun run hasher. So this is not technically a hash. This is more just encoded. So it takes hello world and encodes it. And then you could decode it by giving that same thing and doing buffer from, give it the string that you just hashed, or you just encoded, give it the type that it is. This is a hex, and then say toString, and instead of hex, this would be UTF-8, which would be like the English version of this. Looks like I've UTF-8. And then if I console log this as well, we'll get a hello world. So this will be the hash, and then we'll get hello world out the other side. So that's not encoding or hashing. That's just encoding and then decoding. For a hash, you take the entropy and you actually turn it into you take it into some sort of hashing algorithm. So SHA-256 is maybe one that folks have heard of. The one that Kale uses is a kek something. So it's just like a different hashing algorithm. But essentially the idea is you give it some entropy and then you hash it, and what comes out the other side is a predictable length of bytes, but it's random. So I'm actually going to install bun add. Actually, there probably is a SHA-256. Let me look up the docs really quick. Or yeah, SHA-256 hashing. Let's see what this gives us. Bun crypto hasher SHA-256. And then I think if we digest this, I think this might output what we're looking for. Oops. That's a buffer, so we need to toString this again, hex. So this is a hash, right? So if I keep running this, it'll always be the same hash. But if I introduce some variable to this, so we're not actually using data anymore, and we add like date.now. Now you've added some. Oh, that actually is still producing the same thing. I wonder if this needs to be toString. It also might be that I'm doing this too many times. Or their hasher is weird. I really don't want to get stuck on this. I'm not sure why that's always producing the same bytes. I'm just going to look through this. I'm not going to spend too much time on this particular issue because I have no idea. I've never used the bun hasher before. I wonder if... That's really weird. I wonder if I need to do digest as part of the update.
That might be.
There we go. Okay, so now that we're adding a new piece like this random, it's not random, it's just the date, but it's going to be different because it's milliseconds. So every millisecond, the entropy that I'm sending to the hasher is different. And so we get a different hash every single time we run it. And so the idea with hash mining is that you're looking for a prefix number of zeros. So you can see here we got 1, right? And the rest of these have none. And so what the hash miner is basically doing is just running this over and over and over and over and over and over again until it finds as many possible zeros, prefix zeros as it can. And in Bitcoin, for example, its hash miner is looking, I think, like 16 or something zeros, prefix zeros at the beginning of the hash, which is incredibly difficult. Every additional zero increases the difficulty of ensuring that all of those index, 0, 1, 2 zeros all the way through increases by like a power of 16 or something like that. So it gets outrageous. That's why it's so hard. Like nobody, if you mine Bitcoin, you're not getting the Bitcoin. They have incredibly powerful machines that are now doing the Bitcoin mining because there's so many, the difficulty is so high. So Kale has this function built in where you have to do hashing, but it also has a couple other additional features to ensure that it's not just taken over by super GPU ASIC hash miners. And that's by introducing a couple additional variables. So it does have hashing. That's what this work function does. But it also has staking. So you can risk a certain amount of Kale when you plant, which will also increase. The idea being it'll increase the amount of chance you have of winning some Kale. Because that's another difference. With Bitcoin, it's a winner takes all. Whoever submits, if the difficulty is set to 10 zeros, whoever finds a hash with 10 zeros first and submits that to the chain, it increases to the next block, and that submitter gets the block reward, 10 Bitcoin or whatever it is. With Kale, it's not a winner takes all. I call it proof of teamwork, where we're all working together to farm the next block of Kale, and then based off of your variables that you submit, your hash, your stake, and what we'll get to in a minute, your gap, that will contribute to the amount of Kale that you'll actually win at the end of the day. So that's very important to keep in mind as you think through farming Kale. It's not just let me get an A6 miner and I'll steal all the Kale. You won't, because it's not winner takes all, and there are two other variables besides just the number of zeros that you're able to produce. I'm going to quickly log out. And then I'm actually going to create a new account. I'm going to create a YubiKey account because that sounds fun to me. Allow. Use a security key. Oh, cancel. Let me use that. I'm going to run into issues. Yeah, I wonder if I need to, there we go. Tap it again. Oh, I tried to log in. I need to create a new account. Use that. I don't want to use that. I want to use this. 01, go. Scan it again. And this should make me a brand new account. Just so that I can demonstrate the planting and working, and it'll show on the dashboard here what we've got. We won't get to automating quite yet. So let me go ahead and plant. Scan my YubiKey. Shouldn't have used a YubiKey because now I've got to enter my PIN code and scan all the time. So the first one is planting, and that's when you first kind of like express your interest in farming a block of kale. I didn't put any stake. So staking is one way that you can increase your opportunity at earning more kale for that block. But I didn't stake anything, so now I'm really just working on gap and work. The amount of gap is the amount of time between when you planted and when you actually submit your work. So there's those three variables you can play with. The amount of kale that you stake, which is then risking that kale. If you're not able to submit the work, you lose that staked kale. So it's a risk mechanic. The other one is gap, which is a time mechanic. So if you plant as early as possible and you work as late as possible, you have more gap. And the more gap you have, the more kale you can earn, with the risk being if you wait too long and you don't actually get your work submitted, particularly, again, looking at those failed transactions, you try to submit that work at the very last possible minute and you got the unlucky dice and your transaction fails, you're going to lose anything that you staked. So if you kind of figure out those variables that you want to play with, maybe stake a little, but don't wait till the last minute. So if it fails, you can try again on the work. Or maybe you fully risk the time gap, but you don't stake anything, a really minimal amount, so that the loss wouldn't be devastating, but you're able to play with the higher numbers. And then finally, of course, the work, which I will say on the browser, GPU miners are going to be able to get more zeros than you will be able to in a browser, but not too many more. Even a really good GPU, like a 4090, is probably going to get 9 or 10 zeros, where you're on a browser going to get like 6 or 7. So it's not that much different. Again, because it's 16 times harder for every single, or 16, it increases by the power of 10, or power of 16, every single additional zero that you add. So it's not as simple as just adding another GPU. Like it gets way, way harder, which is why really powerful GPUs versus my phone are not going to have a tremendous amount of difference in the number of zeros that they are able to work. I've probably waited a little too long at this point. I might be able to get the work in. But this is going to do the work, and then it will submit the work. Right now the browser does both at kind of the same time. So it's now looping. There's a Rust WebAssembly backend that loops through, 10 million or something hashes. And then it gives you back the highest number of zeros that it found. So in my case, I found a hash with 6 prefix zeros, and the gap was 22 ledgers. So when I planted, between when I initially planted and when I finally submitted my work, I have a gap now of 22, and the prefix of 6 zeros and 0 stake. So that is what comprises my contribution to this block. Now, what I'll actually be able to harvest at the end of the day from these contributions is going to be very variable, based off of everyone else who's also contributing to this block right now, which if we look at our leaderboard, kale farming is a bit competitive right now. We've got a lot of people trying to get work done every single block. So your share is going to be competing against all those other farmers who are also staking and committing zeros and also having their gap risks. We'll go ahead and harvest, and we'll see what our reward was for this particular 31684 block. I'm guessing it's probably in the 12. Well, actually, I don't have very many zeros. My gap isn't great, so it might be 12, maybe a little bit below that. 9. Not awesome, but not terrible. Definitely glad that it's not 0.001 or whatever it was a couple weeks ago before we increased the emission rate. So that's nice. We got our 9 kale now. We could then risk it for the biscuit at 100% stake, with the understanding that what happens here when we stake is now we got to really make sure we get the work done and submit the work. Because if we don't, my 9 kale, which we'll notice my balance here will go to 0, but my stake will show that I've put this into this block. I've contributed my kale now to this block. That's my stake. Boy, I sure hope I'm able to commit my work. Or what will happen is this kale will go into the block. So the protocol mints a brand new 2,500 kale every 5 minutes, every kale block. But if there are people who staked and did not commit work, that kale will go into that 2500 block. So every now and then, and it's super fun for everyone except the person who locked their stake, you get a big like airdrop of kale from the people who staked but weren't able to get the work done. The kale block will be larger than that 2500. So every now and then you'll see like, oh my goodness, I got 27 kale in that block. What happened? What happened was that Jay Rome probably submitted a big stake and wasn't able to get the work done, and he just airdropped us all a bunch of kale. I'm going to go ahead and get the work done. I'm not going to risk a big gap on this one. I'm just going to go ahead and get the work done. I will say there are some people that are staking a lot of kale, and so this number, all of these values are normalized because they're so variant, right? The max zeros that we're seeing is like 10, where the max stake we're seeing is like, I don't know. I mean, it's a lot. It's billions, many billions, maybe more than that, maybe trillions of not kale, but of stroops of kale. I don't remember what the kale seeds were called. But they're staking a ton, like 6,000 or more, maybe 60,000 was the biggest I'd seen. So my 9 staked kale up against 60,000 kale is not going to really earn me many points. You really have to be staking quite a lot. I will say above a 0 is definitely, most people are staking nothing. And so any stake that you give above 0 is going to help. Look at that. I got 7 zeros, 12 gap. And now I just have to wait for the block to close to be able to harvest it. But I did also stake 9. So I'll get my 9, at least I'll get my 9 if I'm able to harvest. I'll at least get my 9 kale back from my stake. And I might get a little bump because I've got a bigger 0. That might help me a little bit. But because my gap is so short, the max gap you can get is like 50 on average. Most people are getting like 40. This is way lower than that, so I'm not going to get a whole lot on that. But all those values are normalized to ensure that each of these, like no value is stronger than another. I may eventually make an update where the zeros count a little bit more. Maybe the gap counts a little. Maybe the stake decreases in strength over time. I'm not sure, but right now it seems pretty balanced. I'm pretty happy with it. So, but that's how those variables play with each other. So rather than it being a winner takes all like Bitcoin and all GPU based, kale farming is proof of teamwork where everybody can get a share. It's just how much share you get depends on these 3 different variables. So not just GPU miners, not just hash farming, but also staking and playing with this time gap. So a pretty unique little protocol for a vegetable token, at least I think. Okay, well, with the time that we've got left, I know that we usually commit to about an hour, but I'm going to go over if I have to a little bit. We'll end this particular explainer segment and then move in now to actually trying to get a farmer running on one of my Raspberry Pi. I've got a Raspberry Pi, what is that called? 002, I think is what it's called. And I'm going to walk through how I got it running as my kale farmer, so you can see it running right here. It's got a hash rate of, it's running about 0.83 million hashes a second. Found 7 zeros recently, worked at gap 46. It's harvesting about 16 kale every block. And it just kind of does its thing. But I'm going to, I don't think it's staking anything right now, so I'm not risking that. Let me go ahead and harvest this just because I'm curious and I don't want to lose my, as much as I'd love to airdrop you all my 9 kale, I'm going to get this back. So once it harvests, we'll see how much, if we got less, more. Yeah, so the gap really does matter quite a bit. But because we had the zeros, it wasn't as bad as it could have been. Nice. Okay, and we got the 8 plus our 9.2 back, and now we've got 17 kale. Look at that. Okay, so let me exit out of this and close down. Well, I'll keep that open for now. Exit out of that. We'll start fresh here. I'm going to just CD into my directory there. Okay, with the Raspberry Pi, basically what you have to do first, and this is the piece that I'm going to skip just because it takes a long time, is you need to download, well, you need to flash the drive that you're going to stick in there, so like the little micro SD card, and Raspberry Pi flasher. It's got to be it's a terrible name for a product.
Imager.
Imager. It's not a flasher. So yeah, they did change the name. There's a nice little tool that you can use that will let you pick your operating system that you want to use. So like which Pi are you using? So for example, I've got the imager right here. I can choose the device. I've got the 02W. I can choose the operating system. You definitely want to pick the 64-bit. That's going to run a lot better for what I'm using, which is the Bun versus Node.js, which could run on 32. And then you pick the micro SD card. So you flash it, and then you plug it in to the device, and you power it up, and then you have the fun challenge. And when you maybe worth mentioning here, when you choose your operating system, let me just go ahead and do that. I'm not going to actually flash it, but there's a couple of settings that I think are, well, it's always risky because I can never remember if they hide passwords. But there's settings information that allow you to, with the 0, it doesn't have Ethernet connectivity unless you attach the pin stuff for it, but it does have Wi-Fi. And there's a way when you choose your storage, there's like custom settings you can add to it that like configure your Wi-Fi settings onto the device so that when you plug it in, it immediately connects to your Wi-Fi. There's ways that you can also configure it through SSH to be able to connect to it and add the Wi-Fi settings. Or I think you can drop maybe a settings into the boot drive or something like that. I will say anything that I know about Raspberry Pis, I know because ChatGPT taught me. There's so much knowledge about Raspberry Pis out there, and ChatGPT has just sucked it all in, and I had 0 errors, 0 issues whatsoever getting all my stuff set up. The biggest challenge was I had an Odroid, actually, not a Raspberry Pi, but an Odroid that didn't support 64-bit architecture, and so I had to convert my miner into Node.js 18 so it could actually run on a 32-bit architecture, because Bun only supports 64-bit architecture, and that's what my Kale farmer uses, is a Bun scripts. But now it does have Node, so if you do have a 32-bit mini computer, you can run this Node scripts versus the Bun scripts. But anyway, that's all that. Let's go back over here. Once you get this part, the next piece, and this I'm running off of a Mac, but I'm sure Windows is similar and not that much more difficult. And I don't remember a lot of these commands off the top of my head, so I'm just going to scroll back up through them. There's an ARP-A, and this is going to give you all of your IP addresses. So I'm just going to leak all of my IP addresses really quick for everybody to scam me. But these are all the IP addresses, and then one of these is going to look like the Raspberry Pi one. And I've got 2 of them running, and I know for a fact that my second one is the one that I actually want. And when you're flashing your drive, there's a way that you can configure it with SSH access. So you can set the username and the password, as well as the internet SSID and password. So you connect both the SSH password and the internet that you're connecting to. And then all you have to do is SSH into your Raspberry Pi. I'm going to use the IP address. Some of them have like raspberrypi.local. I know my Odroid has odroid.local, but my particular Pi, I've got 2 of them, and I was having some weird issues when trying to connect to the same domain name versus just using the IP address. So that's what I'm going to do. It's going to ask for your password, and then you're in. One of the first things you're going to want to do, especially if you flashed either a while ago or whatever, is just upgrade all of your stuff. And I think on Raspberry you need to use sudo, but apt get, and I don't think I shut down my farmer, so let me shut that down really quick so I don't end up running 2 of these things. Gotta go find the command that lets me kill this.
Probably kill.
Yeah, it is kill. It's kill.
If you grep for kill in your .bash _ history.
So those are the 2 that are running. Now, what was the command for killing? Pkill?
Probably kill 1554. Maybe -9.
Let's look again. Okay, they're killed. Look at that. I don't know why I'm running this thing. Elliot's the mini computer guru. But it's good to have you here, sir. Okay, so that once you've got that set up, the two pieces that you need, well, maybe a couple, but if you flash from the Raspberry Pi, you'll already have a lot of stuff like Git will already be installed. But you will need to install things like Rust and then Bun. And then basically all you'll have to do is just clone the repository, set up an environment variable file, and then just run it. And then if you want it running persistently, you can use a couple of tools so that you can close the terminal and it'll just run indefinitely, or at least until it runs into too many errors. So the way I'm going to do that, I am going to git clone the farmer address here. And so we'll configure the other tools here in a minute. And I think I've already got this installed, but it's as simple as just git clone and then that address. And that will then give you the Kale farmer. And now inside of here, you've got the node script one if you're running on like 32-bit architecture, and you've got the bun scripts if you're running the 64-bit architecture. So at this point, it would be a good time to install bun. So if you go to bun sh, there's this command for Linux and Mac. So I've already run that, but you just paste that. It'll install everything for you. The only other thing that you'll need to install is Rust, which I think is the same way, but just because I'm lazy, I'm going to ask ChatGPT, how do I install Rust on a Raspberry, oh my goodness, Pi 02. And it'll either link me to the documentation, but most likely it'll actually just give me the command. Oh, before we install, okay, that's helpful. Thank you very much, sir. We'll take that. We probably should run that, especially I know with Rust installing some of these things, you might run into some issues, but anytime I ran into issues like compiling a Rust program, I would just copy the error and paste it in ChatGPT and it'd be like, this is what you need. Oh, great. Thank you very much. So I'm just going to install that. I've already done that, obviously, but you would just install that. That'll get Rust. Both of these commands is going to spit out a way to ensure that, like, when you run bun or when you run Rust C, it's in your path. And so you'll just need to copy and paste those commands. So just pay attention whenever the installation for both bun and Rust is done, that you look for any output commands for how to ensure it's in your path, the actual executables, and put those in there. I think it says it right here as well, for getting those into your path. And then we run Rust C, we can see the version of Rust that we're running, 1.85, very nice. The next thing we need to do is run make build. Hopefully this will be cached for me, because this does take a really long time. These computers, very resource constrained, very similar to a smart contract environment. But to actually build some of these things, yeah, so I've already got a cache, thank goodness, because this took probably like 10 minutes for me to actually build the program. But this would be for that Kale farmer, this is the actual program that does the hash mining component of Kale farming. So in order to generate those hashes, I built a little Rust program, because Rust is going to be way faster at finding hashes than JavaScript will be. So I built a little Rust program to do that as fast as I could possibly get it to, which for these little Raspberry Pis is not that fast, but still, 1 million hashes a second isn't the worst. At the end of the day, too, you can submit a hash that has 0 zeros in it. You'll probably get 1 Kale or less, but you don't have to have a hash with any zeros. So if you're running an environment,
but you get your stake back at least.
Of course, yep. It's basically just like submitting no stake. Instead of submitting no stake, you're submitting no zeros. So you could technically submit 0 hashes, 0 stake, and 0 gap, and maybe even still get some Kale. I don't know why you would do that. But yeah, if you're running this in a really resource constrained environment, or like you don't have access, like the browser does have access to like execute web workers, which is what I'm using to run the Rust program in the background with WebAssembly. If you're running an environment for whatever reason doesn't enable or support that, you can either use JavaScript to generate 2 hashes, 2 zeros. Like, it's not much, but at least it's something. You could do that. You don't have to run the hash miners. but I do run them here because they do work in the Raspberry Pi. Okay, so we got our Kale farmer. We've run our project. Now it's time to change our directory into the bun scripts. We run bun install. I'm going to go ahead and force install everything. Bun is very fast, and things should be cached more or less. We get all of our components installed, and then all we need to do is bun. Oh, nope. What we need to do is the environment variables, which I'm going to swipe over here really quick because I don't want to leak my secrets. And I'm going to copy this and put it into another file off screen. I may have been born at night, but it wasn't last night, he said right before he leaked all his secrets anyway. Oh, shoot, I just entered the wrong. Okay, so we should be good. Back in here, cd back into my Kale directory, bun scripts. I'm going to remove, I don't think I need RF, but I'm just going to remove that. And then when I nano, I'm actually going to nano just in case I got that command wrong. .env, okay, it's empty, good. We need to fill out our environment variables file. I think this comes with an example file. If actually, I might have moved it instead of copy it, so it may not actually be here. But if you clone it, there should be a env examples. It may say env example. It might say env mainnet or something like that. I can't remember. But there should be something you can move that will fill in a best guess at what your variables should be. To at least get you started. So I'm going to copy most of these. Actually, I'm going to copy all of them except for the actual keys. Let me get this one first. So these are the two that are the private ones that I don't really want to leak. So you want to fill out your G address for your farmer public key and your farmer secret key. I'm going to do that off screen and then put those back in here. This is like the stake amount that you'll want to play with if you want to stake things. And remember, it's in Stroop, so this looks like an outrageous number, but I think it's like either 50 or 500 or something like that. Kale looks like 50. I'm going to stake 0 for now, just while I'm debugging. And then the nonce count is the number of hashes that you want the program to run through before saying, okay, you ran through all these hashes, which one was the one that had the highest 0? Give me your highest 0 hash that you found. So this one is 70 million hashes is what it's going to run through. So this number you'll have to play with depending on how good your architecture is. If this is too high and your work takes too long, you will generate nodes. It won't finish before the block is closed. So if you're having trouble getting work to finish and find your hash, just lower this. You can put it obviously very, very low, and then slowly increase it until you're getting closer to the end. That way your gap is nice and long. So again, you're trying to find the longest amount of gap while still finishing the work. So you have the highest number of hashes, the highest number of gap, and then if you want to start playing with stake amount, you certainly can. Okay, so I'm going to exit out of this. Actually, I'm going to just paste this back in here off screen, and I'm going to save it, clear that, close this, don't save. All right, so now we've got that all configured, and all we need to run is bun run farm. This will start the plant and work function. It'll print out some different logs. This is showing us, I kind of like outputting this because it tells us what the competition was looking like. Like what did the last block look like? Our max stake was this astronomical number, which according to, well, I can actually run it right inside here. This divided by 10.
Say 955,000.
95,000 Kale. somebody is staking 95,000 Kale. That's a bit risky. Max zeros was 10 and min zeros was 5. So as long as you're right around 5, 6, 7, you're doing pretty good. Max gap, that's about as much gap as you can get without missing the work time span. Yeah, if somebody loses 95,000 Kale, that's going to be sad, but good for us. And then it just begins to get to work. Harvests any blocks just to make sure that we don't miss anything. If we have blocks that we have to harvest. There we have successfully planted. This is just means the 0 just means it didn't plant with any stake, and then it just runs for a while. Once it gets to about 2 minutes and I think 40 seconds in my particular program, it will begin the work process. You could set that much earlier and then increase the number of hashes that it was trying to get. So you could maybe have a larger 0 count. You can fiddle with the program, fiddle with how you want it. You could even try to create multiple farmers inside of one computer. There's lots of fun things you could try and fiddle with. But it is, I don't know, I just love so much that I can have my little Raspberry Pi out there farming Kale for me, like a good little tractor in the background, getting me a little bit of Kale every block. And that's really all there is to it. It's not more complicated than that, which is, I don't know, back when I was trying to get into little computer programming, the 32-bit architecture was so hard to get around. But now that we have computers with 64-bit architecture, we've got things like Bun. We have a Chat GPT. Oh my goodness, that just gives you all the commands, gives you a custom blog post for exactly what you're trying to do. We live in a wonderful, we are so blessed to live in the time that we do for hacking on computer programs and doing stupid stuff with technology. And I'm just thrilled to be alive at this point in the arc of the AI taking over. We can see at 33 minutes 20 seconds we get a little command that says it was booted. This little 0 means there's no errors right now that it's collected. It spins up my little Wasm miner, and at this point it's doing a bunch of farming. I've got the Odroid, which is also running, and it's got a little fan on it, and so every like 5 minutes you can hear the fan to spin up and start farming, and then about 20-30 seconds later it cools back down. But it's the good little tractor just doing this work in the background. I'll let this run for a minute. I may have set the zeros at the wrong number, so I don't know if this will actually get done, but you can see it takes a little while. I think it was 70 million or something like that hashes it was trying to get through. So it takes a while, I guess about 70 seconds to get through 70 million if it's running at about 1 million per second. Still pretty amazing that it can do complex Keck algorithm hashing at that rate on a little Raspberry Pi. Cool. Well, while we're waiting for this, any questions? I'm gonna run through the chat. Elliot, I don't know if you had any thoughts or questions yourself.
No, it's great. I love seeing Raspberry Pis just generally. And yeah, it's a lot of fun to see the available
when are we
getting
a Kale kitchen?
It should be in the next day or two, depending on how my meetings go later today and how much work those end up being. But yeah, it's just like the page is like 90% done. Just need to fine tune it, deploy the contract, and get it out there.
I can't wait to use my Kale to make dishes. Plus now we've got there's an NFT proposal, a proposal out there from Open Zeppelin. We might actually get NFTs that we could turn into little Kale ingredients or vegetable, casserole NFTs. Pretty sure you have to be the first official SEP official NFT on chain. That needs to be a thing that happens.
Nice. I mean, the kitchen at the moment is going to be an NFT drop that is pretty much ERC 721. So I haven't read through the Open Zeppelin proposal yet, but I have been stalking their working branch for NFTs in their contracts. So it'll be, I think, pretty close to it, but it's upgradable, so I can
Nice. Yep.
change the interface if I need to.
That's good. Yeah, writing contracts is so much fun. It does feel a little risky once they start getting used a lot, as you can see from the 12,000 failed transactions that I'm producing every day. Sorry, everyone, but we'll sort it out. I'm still not sure if it's a contract thing or more of just the nature of the way that this contract works, where everybody's competing to be the first planter in a new block, or to be the planter of the new block. I'll have to dig into that a little more. But yeah, anyway, you can see here, it's just running along, 0.83. We're harvesting about 13 kale block, and it's just sitting on my windowsill. Being a good little farmer. Pretty awesome. Any plans to use combined edge compute power? Probably not for farming kale. I could attempt that. I'm not, like, personally, I'm not trying to farm a whole bunch of kale. I like enjoying doing it the way that everyone else is doing it, with Raspberry Pis and just having fun with it. You could spin up like some of the question I have too is like the same questions I had before. Until we have until the price is beating the electricity it costs, it's like, it's fun for the entertainment factor, but I'm not, until it's like financially viable, it doesn't make a whole lot of sense to like spin up AWS bare metal servers to, really try and optimize on kale farming. It's more just, it's fun. And I don't exactly know how much the electricity is costing me, but I know using a Raspberry Pi is not much. Spinning up the GPU miners at the price Kale's at, I don't know that makes a whole ton of sense. It depends on how many farmers you've got going. But that's something people will need to consider if they're like not farming for fun, but they're trying to farm for profit. So that's something to keep in mind. I'm also more interested in spending my time actually creating utility. So using Kale for this like AI experiment that I'm working on. For other activations, it sounds like there's some folks that are planning on adding Kale to their apps. So then maybe Kale, either the price will go up or just the utility will go up. And then whether or not it makes financial sense from a speculative perspective, it'll make sense from just, I want to play these games and I need Kale to do it. And so I'm going to spin up, maybe I spin up something that can farm me a little more Kale so that I can play the games more. But from my perspective, it's less, I'm not doing it for profit. I'm doing it because I am going to need Kale like everybody else to play these games. And these Raspberry Pis that Raspberry Pi cost me $30 and it doesn't draw any power. Doesn't give me a whole lot of Kale either, 13 per block. But yeah, you just run that 24/7 and check on it every now and then. I'm probably going to set up like a little notification service so that if it stops farming for some reason, I get a little notey, but I'm doing it for the fun. And I'm hoping that most people, at least initially early on, will also be doing it for the fun and open source things and create little notification channels. Somebody makes a Dune Analytics dashboard and we're all just kind of having fun with it and then kind of see where it goes. But don't get crazy with it and then get all disappointed and sad when you get your electricity bill and your kale farming didn't pay for it. Again, I'm looking for invocation numbers and the fun of learning about smart contract development and running these little mini computers. We'll see what happens with the rest of it. It is a ton of fun though. I haven't touched Raspberry Pis in a long time, and this finally got me back into it. And oh my goodness, the ecosystem has gotten so much better since the last time I messed with it.
That's the truth.
Oh my goodness, Jesmar in the chat. I haven't seen Jesmar. Has he been around? Hey, buddy. Fantastic to see. What items are you trying to hash? That's a good question. That comes from the actual contract, the entropy of the contract. I always got to watch my environment variables. It's always just terrifying these days. Sharing anything. You guys got to keep me honest. You can't steal from me. I'm just trying to help out. So inside the contract, there is a... this one right here, generate hash, which takes the index, so the current block number, the nonce, which is what you are iterating through. So when I've got that 70 million hashes that I'm trying to hash, it's just iterating 0, 1, 2, 3, 4, and then whichever one I end up using as the entropy, that's like the variable. Entropy comes from the last block, so you can't like farm way out into the future and then just slowly use those blocks over time, because you don't know what the entropy is going to be from the last block. So this one's actually kind of important to keep people from just future farming and then having 20 zeros because they farm 10 years into the future. So this one feeds from the last block. And then you've got the farmer address, so you can't steal someone else's farm. They're when they initially plant, you can't steal their plant because it comes from their farmer, and you've got to sign for that. So it takes those pieces of entropy, index, nonce, entropy, and farmer. It puts them all into a big array, and then that array goes into the KEK 256 CAC. Isn't that like a disease? Goes into that hash miner, or I'm sorry, the hash algorithm, and then spits out bytes. So it takes all that entropy that it assembles and then hashes it, and then that becomes the hash that then counts the number of zeros in that hash, and that becomes your zero number, which then goes into the normalizations mathematics that actually generates how much reward you get for that block. So it's all in the contract. Anyone's more than welcome to come and look at it and audit it. If you find a bug, find a way to exploit it. It's your farmer's duty to disclose it and fix it, not to exploit it, because we're all just trying to have fun. And I wrote this in a couple of days, so you're not allowed to hack it. It should be a lot more solid, and it's not very complex, so I'm not that worried about it. But still, I don't proclaim to be the world's greatest smart contract developer. Okay. Any other questions? I like how Jerome knows how much electricity he's using. That's awesome. I need to get one of those plugs that measures how many kilowatts per hour it's costing me to farm, and then I want to convert that into like diesel fuel points, so we know how many actual kale we could grow if we didn't farm digitally but actually grew kale. But I don't know why you do that, because it's a garbage vegetable. All right. Well, I appreciate everyone hanging out. Thanks for staying 11 minutes over time. Hopefully the recordings all worked and we can get this posted up. Happy farming. Go build some Kaletility for us. Let's continue to push those invocation numbers through the roof. If you need LaunchTube tokens for free transaction submission, please do let me know. I will say I'm working real hard to try and get those failed transactions down. So if you notice all of a sudden that your LaunchTubes aren't working, it may be because I've caught you inadvertently or nefariously submitting a lot of transactions that just keep failing. So keep an eye on those things. Let's continue to improve the ecosystem, make it better for everybody. Happy farming. Appreciate all of you. Enjoy the week.